So hello guys, Namanjot Singh this side from NetClass. In this video, we will discuss about transport layer. In upcoming 4-5 videos, we will discussing about some layers of OSI reference model. We will take particular layer, then we will discuss about it in detail. This will be a short video. The next video will be on the network layer, and after that would be data link, and after that would be physical layer. So let's study about the transport layer first. Let's move further. And don't forget to like and subscribe this video because we are working so hard to bring you best content forward. So let's discuss about the as we discussed about in the last class what transport layer is when we were discussing in the OSI reference model. So let's discuss about transport layer in detail, what transport layer is. So transport layer, I would say it creates a logical connection between two users. So what is the need of transport layer is to theoretically it said setting up and maintaining the connection, okay, and it helps in error detection and break data into smaller parts, that is called segment. So what is, for example, we are getting data from the above application layer, presentation layer, then session layer. Now we have a data. This data needs to be transmitted through the media, right? So a connection is need to be set up between these two connections. So a connection is set up, and setting up and maintaining connection is take care under this transport layer. The significance is this, that when you are troubleshooting, from troubleshooting point of view, you do need to know what is the goal, at which layer you are working, and what layer need to be focused on. Okay, so let's discuss how this works. I said it also helps in error detection and segmentation. So as we discussed in the last class, we studied a concept about PDU, protocol data unit. Each protocol, being it any layer of protocol, get its own PDU to the packet to the data, so that it can be transmitted and it can be simplified. So at the transport layer we have a PDU of that is called segment. So segment is added to this data layer, and the data is broken down into smaller parts. Such a smaller part we call a segment. So this is the PDU, protocol data unit, at the transport layer. So what happens is, transport layer is very necessary when we are discussing about the setting up and maintaining connection and error detection as well. So in transport layer, let's say we have two concepts. It helps in flow control. So transport layer helps to flow control the data. So there are so many levels of flow control, so many types of flow control. In this video we will particularly discuss about the ready not ready signal and windowing. So what happens is, guys, as the name suggests, ready not ready signal is simplified. When a user is sending ready signal, then only I will send the data. And same size with the windowing. As you can see the window behind me, if I want someone to come through this window, I will let him know. So this window size will decide what kind of person will fit in. For example, if I have a small window, only a small person can pass through it. So same is the concept which transport layer handles. So let's discuss about it. When we are discussing about transport layer, we have under ready not ready signal, what happens is, suppose PC4 is sending one packet to PC5. Okay, now PC5 says I am ready, then only PC2 will send the packet. So this way ready not ready signal works. So what do you think? For example, if I am waiting for every acknowledgement to send data, is it an efficient way? No, I don't believe so. It's not an efficient way. Why so? Because when someone is sending data, everyone is have to wait, the other persons have to wait for the ready signal. So waiting for this ready signal wastes a lot of time. Sometimes in a regular environment, networking environment, it is very inefficient and not very cost effective. So there is a better way to control the flow. Control the flow means to control the traffic. So what happens is, we use a concept of windowing. How this windowing works? For example, you have a window. So this window allows 10 packets at a time to pass through it. So only 10 packets will pass through it. Then I will send the signal, okay, I have received it. That is called confirmation packet, is called acknowledgement. So for example, again taking the example of this, PC1 is sending 10 packets to PCB. When it, so as we were discussing about the window, for example, 10 packets pass through it and it allows the 10 packets to pass through it. So window size is of 10. So we know we will send acknowledgement packet. Okay, bro, we have allowed 10 packets to pass through it and we have received 10 packets and that through in sequence. So now it will send 20 packets. And now if window doesn't allow 20 packets to come in, it will send a message that no, I was not able to pass these 20 packets through it and we are having a packet drop here. Now A can send 10 packets again and now the window size would be set to 10 only. So this is how windowing works. Windowing is very necessary when we are discussing about the flow control. So the conclusion here is windowing is somehow better than ready not better signal because there is no delay in it. There is no delay in windowing. So in TCP we say that there is two types of connection, reliable and one is unreliable. So when we are discussing about reliable and unreliable connection, it's not about one is better and other is not. Suppose, as I discussed before, if we are waiting somehow for every ready signal, we are wasting our time. Same is the case when we want a network connection between these two components to be dependent upon the quality. We will say reliable connection is important. And when we don't, our priority is not reliability, our priority is to just send the packet, then we will say unreliable is best. For instance, you are watching my video. If you lose only one packet in this video frame, it is okay. There is not much difference. But when we are discussing about voice and there is some packet drop of my voice, it will become useless. Like voice you cannot understand, video it is okay even if I am dropping a bit packet, so that is okay. So what is, like when we are talking about voice, we would say okay, having a reliable connection is important. When we are discussing about video, unreliable connection is important. So let's discuss about this, what these reliable and unreliable connections are and what protocols are used in this. So how this reliable connection comes from, for example, we have two PC, I am sending sync packet. This packet is named as sync. By the way, this process is known as three-way handshake. This is very necessary from interview point of view as well. In reliable connection, there is three-way handshake. So in three-way handshake, what happen is three handshakes happen. So one handshake is the sync. It says, okay, are you ready for the packet transfer? So B replies, okay, I am ready, with a sync packet in it. So A replies with the acknowledgement packet again. So this way both are agreeing to certain terms and conditions that okay, we both are now ready to send the data. So this is how reliable data comes from. But when we are discussing about unreliable, what happens is when we are discussing about unreliable connection, there is a similar case. There is a bucket, let's say, and someone is throwing ball at it. He is throwing 10 balls. If only 5 balls goes and 5 balls goes out, that's okay. That is unreliable connection. Our priority is not a reliability here. Our packet is to just transfer the data. So this unreliable connection is known as UDP. And this reliable connection comes under a protocol named TCP. These protocols are very necessary when we are discussing about transport layer. In transport layer, there are so many protocols come in, but majors are TCP and UDP. Yes, the TCP is same as TCP IP we study about, and we will discuss in the further video as well. So TCP means transport control protocol, and UDP is usergram protocol. Okay. So yes, there is another concept which is very important in transport layer. So that is, transport layer helps in setup and maintaining multiple connections. So what multiple connection means? Setting up multiple connections means setting up multiple connections means multiplexing. So how does this multiplexing come from and how we maintain this multiplexing? For example, let's say what multiplexing is. For example, you are using this PC. You are using YouTube. At the same time, you are using say some website. You are downloading a movie from somewhere. You have opened website. So what is this? This is multiplexing, right? Same PC is multiplexing and is connected to so many sources. So this is multiplexing. But how this works? So let's come in this. At transport layer, we have certain things that are called ports. These are very necessaries. So ports are basically number that are uniquely assigned to set up a connection. Let's say, so we have port numbers from 0 to 65536. In 0 to 65536, we have known and unknown ports. So what unknown and known port means? Confusing, right? 0 to 1024, and after this there are unknown ports. Before this there are known ports. So what this port mean is, for example, we have assigned port numbers to certain protocols. For example, port number 80, you would have listened it, right? Port number 80 is for HTTP. How this port number comes from? This port number comes from this concept. Okay, having a port number is necessary for a protocol to work. And why we use these unknown ports which are not known? These are the ports which are used by our PC. For example, let's say we have a PC here and we have a server here. Okay, we have a server here and we are using port number 80 HTTP of this server, but we would be having a source port number as well. For example, let's say if same PC is using HTTP of this server for page 1 and for page 2 it is using port number HTTP 80, because HTTP have a port number 80 only, so that cannot be changed. But there should be something which should make it unique. And what makes it unique? The source port number make it unique. So destination port number and source port number. Destination port number would remain the same. Port number 80 for HTTP, for HTTP S it would be 443. For every protocol it changes. Protocol we will discuss in future. Protocol in short means set of standard procedures. So but we need some source port, like, so these differentiation in source port would help us in multiplexing and maintaining multiple connection and will not allow our connections to get confused. So let's say this is having a port number of 65500 and this is having 65531. So now we are having two connections with same source, with same destination protocol, but the source is different. So we are using two web browsers to access this page, with source port number 35500 and destination 80 and 65537 with destination port 80. So this is how multiplexing is achieved. Multiplexing is used through the port number and all. So similarly at layer 3 we use IP addresses. Layer 3 we will discuss in next video, and that also helps in maintaining multiplexing. So these go both hand in hand. So there comes the segmentation. Segmentation, as I discussed before, the PDU. So transport layer helps to segment the data into smaller portions, and that PDU, protocol data unit, is known as a segment. So yes, in short, this is the explanation of transport layer. So let's compile all the data together. What transport layer do is it helps in maintaining and setting up multiple connections between source and the destination. And how it does through? With the help of source port number and the destination port number and the address of IP address as well. IP address works at the network layer. So all these layers are connected to each other, right? So as we have discussed before. So another use of transport layer is it helps to decide what kind of transport mechanism which we will use. For instance, reliable and unreliable connection. So unreliable connection is sending data without considering about the reply from the destination that it have received or not. But reliability is when we wait for the acknowledgement packets to receive the data. This is the use of transport layer. So other use of transport layer is to control the flow between the source and the destination. Flow control means we are sending the data and we are waiting for the response. Okay, this is the ready not ready signal, and there is another concept in transport layer flow control, that is windowing. How windowing works? Simple. It is the window size that decides how much data can pass through it in a one go, and we will send a confirmation packet. Yes, it is sent, and now the packet is good. We don't need extra packets. We don't. It is good. Now you can send more packets, and when more packets are received, and when the more packets are dropped, it will go to back and say, okay, the window side would be less. So this is how transport layer works. Thank you guys so much for your time. Please like this video and subscribe to this channel. Stay tuned for upcoming videos. In next video we will discuss about network, data link and physical layer. Thank you so much guys.